Okay, everyone. Today, we are going to learn the last big piece of stoichiometry. And this is the most practical piece that we're going to learn. Because if we're going to do these reactions in the lab and see how much they make, we're going to start with grams, again, because we don't have equipment that measures moles. And we're going to end in grams. Okay, so companies that actually make chemicals for their business, they have to do these calculations to know how much they're going to make and how many raw materials they need to order to make what they need to make. Okay, so today we're going to start with grams given and we're going to find grams of our unknown. So if you're looking at your stoichiometry map, we're going to start here and we're going to go all the way to here, which means that we're going to use 4 boxes in each of our calculations. Okay, so if you'll go ahead and turn past our balloon lab, we haven't done it, but we will, to this page, which says mass and mass conversions. Okay, mass and mass, in other words, gram to gram. So when we're doing gram to gram conversions, you're going to draw 1 long horizontal line and 3 vertical lines every time. Okay, and this first box is going to be grams of your given. This is going to be molar mass of your given. This is your mole ratio. And this is molar mass of your unknown. So every time we do one of these calculations, this is the formula we're going to use. And if you'll notice, this actually matches our mole map. Okay, so we're going to have this first part be molar mass of our given. The second part is going to be our mole ratio. And the third part is going to be molar mass of our unknown every time. Okay, so we have the balanced reaction of hydrogen gas with oxygen to form water. This is a synthesis reaction, which means it is a redox reaction. So if you react 2.8 grams of hydrogen with 11.2 grams of oxygen, what is the theoretical yield of water in grams? Okay, theoretical means we're going to calculate, okay, on paper, what should we be able to make? Because we have 2 starting numbers, 2.8 grams of hydrogen and 11.2 grams of oxygen, we're going to work 2 of these problems. So go ahead and get your groaning out of the way now if you want to complain about it. I know it's a lot of writing. Please don't try to do any shortcuts because you'll make silly mistakes, okay? I'm going to go ahead and put my calculations on top of each other because I think it'll be the easiest way to use space. I'm going to draw my 1 line, and then I'm going to draw my 3 vertical lines and get ready to fill them in like we have in our example above. So 2.8 grams of hydrogen goes here, okay? Then if I look up at the example, I highlighted in blue, molar mass. Grams of hydrogen gas comes down. This is the molar mass, which means we have moles of hydrogen as well. 1 mole, hydrogen's mass is 1.01, so 2 of them means I have 2.02 grams of hydrogen. Okay, this is a conversion we've been doing since the beginning of the year. Grams of hydrogen cancels. Now, I have highlighted in green the mole ratio. So I bring my moles of hydrogen gas diagonally down. My unknown is water. So moles of water over moles of hydrogen. The coefficient from the reaction for water is a 2. The coefficient for the reaction for hydrogen is a 2. So if I stopped here, moles of hydrogen would cancel. And now, highlighted in yellow, I have the molar mass of the unknown. So I bring my moles of water diagonally down, and I know that this is going to be grams of water. I know that 1 mole of water equals 18.02 grams. The mass of 1 oxygen is 16. The mass of 2 hydrogens is 2.02. So moles of water cancels, and I'm left with grams of water. So now to do the math. I'm going to put my numerator in parentheses and say 2.8 times 2 times 18.02 divided by, in parentheses, 2.02 times 2. Close my parentheses, and I get 24.98 grams of water. So I have enough hydrogen to make almost 25 grams of water. Now let's see how much water we can make with the oxygen that we were given. So here's our next line. Again, my 3 vertical lines, starting with 11.2 grams of oxygen. So I have to bring grams of oxygen down, and I know that this is the molar mass of oxygen. It's highlighted in blue. So 1 mole of oxygen is equal to 32 grams. Okay, 1 oxygen is 16, and we have 2 of them. So grams of oxygen is canceled. Next thing is going to be mole ratio. So I bring my moles of oxygen down, and I'm looking for moles of water. My coefficient for water is a 2. My coefficient for oxygen is a 1. Moles of oxygen cancel. Now the last thing that I highlighted in yellow is molar mass of our unknown. So I'm going to bring my moles of water diagonally down. I know that this is grams of water. 1 mole is equal to 18.02. Before I do the math, look up here at this. I think it's interesting. Okay, we're going to use the yellow. This and this and this are the same in both of these calculations, and they always will be, okay, because we're ending looking for the molar mass of our unknown, okay? So now let's use our calculators and open our parentheses, say 11.2 times 2 times 18.02, close my parentheses, divided by just 32. Gives me 12.61 grams of water. So I have enough hydrogen to make almost 25 grams of water. I only have enough oxygen to make 12.61. So this, the smaller number, is what I actually make. My oxygen was the limiting reactant, and I have an excess of hydrogen. Okay, so now a student goes into the lab and performs the above synthesis of water. Okay, into the lab, doing in the lab is actual. You're actually doing it. The math on the paper that we've been doing is theoretical. Okay, so this student only produces 10.3 grams of water. What is the percent yield of the experiment? So I'm going to teach you a new formula here today. You don't have to memorize it. It's on your formula chart, the one we were using for the activity series and the solubility rules. It's in the data analysis section. You just have to be able to use it. Okay? So percent yield is your actual yield, which we're going to say comes from the lab, actually doing the experiment, divided by the theoretical yield, which is math. It's what we do on paper, times 100. Okay? So we're going to take our actual from the lab. The student only made 10.3 grams. And we're going to divide it by our calculated 12.61 grams and multiply it by 100. In other words, we're just trying to see if this student's experiment was accurate and efficient. So 10.3 divided by 12.61 times 100 gives me 81.68%. So not too shabby, okay? So actual in the lab divided by theoretical, which is the math, times 100. All right, again, this equation is on your formula chart in the data analysis section. So let's look at problem D. How much of the excess reactant in grams is remaining after the reaction occurs? Well, we said that oxygen was our limiting reactant, which means that hydrogen has to be our excess reactant. Okay? So like we've been doing, we're going to take what we made and start with it and solve. Our unknown becomes our excess reactant. So I'm going to take my 12.61 grams of water. Okay, so up here from right here, 12.61, how much I actually made. Okay, and I have grams and I'm asked to find grams. So this is a gram to gram with 3 vertical lines, 4 boxes. So grams of water means I need the molar mass for water, which I've already calculated to be 18.02, and that's equal to 1 mole of water. So grams of water cancels. Then I have my mole ratio, so moles of water. And remember that I'm solving. My unknown is my excess reactant. Okay, the coefficient for hydrogen is a 2. The coefficient for water is also a 2. Okay, so mole of hydrogen, mole of water. Sorry, mole of water, moles of water cancels. Now I'm back to moles of my unknown or my excess reactant. So I bring moles of hydrogen gas down. That's 1 mole. And that's equal to 2.02 grams of hydrogen. Okay, so my moles of hydrogen cancel and I'm left with grams of hydrogen. So let's do this math in the calculator. So open parentheses, 12.61 times 2 times 2.02, close your parentheses, divided by, let's open them up again, open parentheses, 18.02 times 2. Close your parentheses, and we get 1.41 grams of hydrogen used to make this much water. Okay? So if that's how much we used, our problem gave us 2.8 grams. So we're going to subtract how much we used from what we were given. So 2.8 minus 1.41 gives us 1.39 grams of hydrogen gas left. Okay? All right. So we've worked through 3 actual gram-to-gram calculations and percent yield. Your job is going to be to turn the page. Okay, you have several problems here, including percent yield and excess reactants. Okay, so you've got this page, you have this page, and you have this page. 4. Yeah, 4 pages, or 3, I guess. I think my last one doubled, which is more than I know you ever want to do. But again, the only way to learn this skill is to practice it. So I need you to spend the rest of the time that you have in class working these practice problems. Work them together. Use your time wisely. Check your answers on the key and Canvas. We're not going to spend extra time on this skill when I've taken the time at home to make a video for you. Okay? If you have questions, I'll be back on Monday. You can come in and I would be happy to help. Thanks and have a great day.